So, our initial objective is to talk about JavaScript as an asynchronous language. We need a couple of things though before. So we're going to take this opportunity to talk about the exception handling mechanism. Now, the exception handling mechanism in JavaScript is the same exception handling mechanism which you've encountered a bunch of times before. So it's try, catch, finally throw. Right? It's the same keywords, the same thing. There's only one, let's say, more stranger thing, and of course there's the asynchronous business, which we're going to discuss after this. So first of all, exceptions. So let's consider this function. Now this function treats a constraint that exists on its inputs via an exception. Now exceptions in JavaScript are on a type called error. And I noticed something a bit strange, which is that error is constructed based on a message, on a string. That's it. And if I try to create this object independently and put another property on it, it's not going to work. So that's a bit of a constraint which we're going to have to solve, and we'll solve in the next example. Other than that, everything works like your regular plain old exception mechanism. That is, I have a try-catch. Within the try-catch, I execute everything line by line. But if one of those things gives an exception, execution stops and I go in the catch. Just like for anything in any language. And if I look at the exception that I get here, I see that I got a 1 because 2 was a valid input, but then for 3 I got not even. Okay? Right, so that's how exceptions work. And there's a reason why we're talking about exceptions initially. We'll see it a bit later. Now let's fix the issue that we said we had. That is that I can't send details from the exception outside. And I'm going to need details. So let's consider something like a relatively simple operation. I'm going to perform some sort of transfer within a relational database. Right? So I'm going to connect to the database, right? Then I'm going to try to make an update on the first collection, an update on the second collection. Now, what might happen here is I can't connect to the database. I don't have the right to write. I can't write. I'm not granted the right on the first collection. I'm not granted the right on the second collection. Maybe the update I'm doing has some type constraint, right? And with this representation of an error, it's going to be hard to send that information out, to say what the error actually was. Now, I could maybe create the error based on a stringified object, but it's a bit more complicated. So the simpler thing is to extend error. That's how it's done. And if I extend error, I still keep the error thing, which has stack trace and everything you'd expect from an exception. But I can also put a payload in, right? Something else, some additional information. In this sense, I said cannot process odd values for value m. It doesn't necessarily make that much sense. If we'd make some sort of validation framework, it would be a bit more complex than that. But this is how we'd handle the language constraints. Right, additionally, in this example, I can see that I have a finally block. Now, the finally block is always going to get run, and it's there to generally to deallocate resources. So on the same example that we've already gone through, let's say I connect to the database successfully, and then when I try to write in the second collection, for example, something's going to happen. Now, let's assume a transaction. We've not destroyed our data by doing this, but I still have a connection open. Now I could let the connection die by itself, which is going to happen based on some connection timeout, but the connection is what we might call a rare resource. That means there's a limited number of concurrent connections to the database server, so the civilized thing to do would be to close the connection explicitly, and I do that in a final loop. Right, so this is basic exception logic, just like in other languages. Now let's talk about the thing that's not like in other languages, in the sense that JavaScript is an asynchronous language. But what does that mean? So let's consider this is a trade-off, right? So this is something I have an option to make, and each side of the option, right? Each of the two sides has its own ups and downs, its own disadvantages. Let's consider a language like C#, for example. So when the language was invented, it wasn't invented in order to make graphical user interfaces. It can make graphical user interfaces, but that's not the primary concern of the language. It was most likely invented as an enterprise language as an alternative to Java. Right, so let's say you're building such a language, and the first tendency, so there's a couple of constraints you have to take into account, right? So one of the constraints is the fact that you want the code to be as readable as possible, thus as maintainable as possible. As with everything, programming is also guided by costs. So your default choice is going to be a synchronous language. Right? A synchronous language has the following characteristic. So I get to a line of code, I start running the line of code, and then I wait for it to finish. Simple enough. Now, this, when I do get to building graphical user interfaces, this is going to raise some issues. And the issue is, what if the line of code is something which takes a long time, but more generally comes from an external system? If it's a request, if it's a HTTP request, it's an insert in the database, it's loading a large image from somewhere, it's from the outside. Now, I have two issues here. One is that the thing might take a lot of time, and the second is the thing might not happen. Right? I can't really tell. It's not something I can control. It comes from the environment. Right, so the problem I run into here is the fact that my graphical user interface, which is under my control, has to continuously do something, which is repaint. And if you look at the source for a small video game or something like that, you're going to see an explicit repaint cycle. You're actually going to see a repaint. If you want, I can give you an example. I have an example for Canvas and stuff. What happens if I have something which is long running and I have to do repaint? Well, I have to give one up, right? If I wait for the long running thing, I'm not going to be able to do repaint, and that means I'm not going to be able to fluidly move my mouse, for example. So that's not a solution. The impression that a user is going to get is that the application is unresponsive. So the solution to this is to put the long-running external thing on another execution structure, such as a thread. Right? So I create a thread specifically for the request, and I say, well, when you finish with the request, notify me. I notice, however, that I'm still going to have some code which is going to be dependent on whatever that request returns. I'm probably not doing the request just for the sake of it. Okay, so that's one choice. The second choice is to say, well, my language is not going to be synchronous. So what does that mean? It means that whenever I start running a line of code, I'm not generally going to wait for it to finish. I'm just going to go to the next line of code. Right, so the way this happens is the same mechanism I've just described, only the threads are implicit. Right? So, or the execution structures are implicit. I'm not creating them by hand. And this is what JavaScript does. And the reason why this was the choice is that JavaScript started out as a language to automate graphical user interfaces. Right? That was its purpose. Right? So it makes sense to reverse these assumptions. Right, but I run into the same problem as for our C# example, which is, how do I run some code which depends on the result? Right? Because if I get to line 3, I start something, I go to line 4, that's fine if line 4 is not dependent on the result of 3. But if it is dependent, I have to have some way to run code dependent. Now let's see this in action. And we're going to create an artificial asynchronous context. So the issue here is that setTimeout runs some code after some time. Right? It's 1 second in this case, it's in milliseconds. So the fundamental question is, what is written first to the console? Is it done or is it next? Next, right, next is written first, right? Because I'm not waiting for F0 to finish. But what if line 9 would have been dependent on line 8? I have to have some way of waiting for it, or of running code whenever that line finishes. Right, so I have a series of approaches which were initially in the language. Now these approaches are still possible, it's not that they're not possible. The problem is that they tend to produce code which is unmaintainable or hard to maintain. One sec, let me just find the async example and just run it. So we're going to see what's happening, right? So indeed, we first have next, then we have done. Right, so solution number one, and there's a modern solution, which is what we're going to use, but let's see the oldies. Solution number one, which is callbacks, which is I send to any asynchronous operation, I send as a parameter a function, and that asynchronous operation is responsible of running the function whenever it finishes. Typically, I'm not going to have one callback, I'm going to have two callbacks, right? One for success and one for error. Because, like I said, whenever I do something with an external system, I don't know how long it's going to take, but also, I don't know if it's going to succeed. It may succeed, it may not succeed. Now, the issue with this kind of code, so this is going to work out, right? So in callback, I'm going to know who R is, and I'm going to be able to run dependent code, code dependent on R. And this is fine from a functional perspective. I still get next first, but I can see that within callback I knew the value. But what if callback also does something asynchronous? Well, it's going to spawn another callback. And what if that one does something asynchronous? It's going to spawn another callback, and so forth. So I'm going to get this whole tree, processing tree, which instead of being implicit, it's explicit, right? And this actually has done something subtly awful to my code. Because before, I could read my code from the first line, and I could have understood what it does. But if I do all this callback business, I can't read the code linearly. So instead of being in a model which is evolved from imperative languages, I'm in another model. I'm not in Kansas anymore. I'm in a style which is called continuation passing style, in which, instead of having lines executed consecutively, each line tells me what is the next line. And this is where I am, actually. So this is really hard to debug. It's not hard to debug if we write a toy example which fits on a screen. But it's hard to debug if we actually write an application on this. But, well, people handled it. This is only going to affect basically implementation speed. It's not a tragedy. It's something that can be dealt with. But it's definitely suboptimal. Now, something else to notice is that I have another way of doing things, which is I said that wherever JavaScript is, it's organized around an event bus, right? Because it dealt initially with graphical user interfaces, so it has events, and there's always an event mechanism, right? As opposed to, if you look at Python, you have to build your own event bus, for example, if you want events. But in JavaScript, it's always there. So let's see it with events. Now, it's incidental that we're in the browser. It's just easier to demonstrate. But we can do this in Node.js just as well. So this time, we take the value out of the async task by creating a custom event, populating it with something more, and then dispatching it to an event target. Right, so this also has a couple of problems. So what if this one also has to launch an event? And again, so I have the callback problem, and I also have a problem which is event pollution, which is, how do I know that these names don't conflict? What's my standard for communicating values with events? Hard to answer. This is even more unfortunate than, so this is, so the callback approach was unfortunate, and this is unfortunate plus plus. Right, so that's not a solution. Right, so what would the solution be? Well, the solution is to change the way we think for a bit. So instead of saying something's going to happen and I'm going to run some code, we're going to think in another metaphor. Now this was originally a design pattern, basically, which appeared in a library which wasn't in the core language. But slowly it migrated, and first the design pattern got into the language, and then we had an even more, let's say, ergonomic way of using it. Now, as an aside, what's a design pattern? Yes, it's pretty close. Design patterns actually come from architecture. I recommend, there's this guy who's called Christopher Alexander, and he wrote a book which is called The Pattern Language, which talks about buildings. And the concept is that if you have people building a warehouse, and they're not connected geographically, they don't talk with each other, they're going to reach similar solutions, right? Because the problem constrains the approach, right? If you build a good warehouse, right? You can build a bad thing in a myriad of ways, There's infinite ways of building something that doesn't work. But if you build something that does work, it's going to be similar. Now, in practice though, so we have this in programming, and the idea is that people in different languages are going to reach similar solutions. But in practice, what's happening is many of the design patterns in a language compensate for things that are missing in the language. To give you an example, you've done Java programming, right? You're going to have a subject next semester which talks about patterns in Java, and you're going to find the builder pattern. Well, builder is there because Java doesn't have keyword parameters. If you look in Python, there's no need for a builder pattern, right? So it compensates for something. In this case, what the promises, what we're going to look at now, compensate for is the lack of the general async await mechanism, but more specifically, they compensate for the fact that JavaScript didn't have a way to think about future values. Now let's think about future values. What's this future value business? Well, the metaphor, like I said, we're going to change the metaphor, and the metaphor is that we're talking about operations with stuff which is going to appear in the future. So if I add two numbers, 3 and 5, I'm going to immediately be able to add them and get 8. But if I add 3 with a future value, what's going to happen? Well, the future value is not concrete, right? I can't actually add with something unknown. But what I can do is write an operation such as, what's going to happen is this expression is going to be evaluated whenever the future value becomes concrete. Right? So what can I do with the future value? Well, as long as it's a future value, I can just wait for it. Right? I have to wait for it. And what might happen? So let's call this state of waiting for a future value pending. So the value is pending. Right, so I wait for a while, and one of two things are going to happen. So the first variant is I get the value, and now it's a concrete value, it's a number. So it's again 3 plus 5 equals 8. Or, after waiting for a while, I am notified by some mechanism that the value is never going to appear. So the case in which I get the value, it's called fulfilled. The case in which I don't get the value, it's called rejected. Right, so this is the metaphor we're working with, and we're going to see it in action on a similar example shortly. Right, so what's a promise? So a promise is going to be an object which has an internal state, which is pending, fulfilled, rejected, just what I said. And it has two methods, and the methods are then and catch. So then receives something which looks like a callback, and it's going to be run whenever the promise is fulfilled, thus the value is concrete. And catch is going to be executed whenever the promise is rejected, thus I get an error, not a value. And if the promise is pending, nothing is getting run. Right. So what I'm getting here is a way of taking my asynchronous code and making it more similar to my synchronous code. But I am not losing the ability to run asynchronous code. I can still choose, right? So what I want is the ability to choose. So let's, after this rather long introduction, let's look at this example. Now, promises, I'm going to explain promises themselves, but you're generally not going to have to interact with promises unless you are trying or you need to promisify something. Now, what's promisifying something? So you have some code. The code is written with callbacks or events. And you want to make the code work with promises. So then you have to go through a series of operations to transform the callback-based code into promise-based code. Now this can be done automatically, in Node.js at least. There's a module called util, and it has a function called promisify. And if the thing you're passing to it is written standard, right? If it's a standard implementation of a callback function, it's going to be able to do this automatically. If it's non-standard, good luck, write it your own. But let's look at what a promise is. So a promise is basically a function of, it's a higher order function of order 4. Right? So its constructor is based on a function of resolve and reject. But to not make things really complicated, I can think about this as if it were a block. And what I have to do in this block, which I have here, is do whatever I want it to do and call resolve when I want to take out a result out of the promise, and call reject whenever I want to transmit an error out of the promise. Make sense? right? So as a design pattern, it is pretty complicated. Right. So what happens here? So F0 returns a promise, F1 returns a promise, etc. And they're artificial. So my code now says this. So it's F0. Then when I get the result, I'm going to run this bit. Unfortunately, this bit also has something which is asynchronous. And this one, when it gets the result, returns the result, and so forth. And at the end, I can catch any error that might have occurred. So any of these promises that might have been rejected. Now, if for example I just say let f is F0 call, I'm going to get at the console something which says promise pending. Right? If I don't wait for the result of the promise, what I get immediately is a promise object which is pending. Right, so this is promise HTML. 1 second, let me run this so we can see it in action. So it's F0, F1, F2. So that's fine. Now, this code, while it might be better, is not great. So let's think about doing something not necessarily trivial, but let's say we write a command line tool. It reads a bunch of directories, it searches for new files, and then it copies them somewhere and makes an archive. You know how many asynchronous operations are here? And if I write it with this then syntax, it's still going to be really ugly code. It's going to be linear though, right? So what I got here is I can read this code from top to bottom and understand what's happening without having to trace callbacks everywhere. But it's still, so it's good, but not great. So, after the introduction of promises in the language, after a while, we actually got a couple of keywords which work with promises. The most important one being await, right? So it's async and await. Now, async doesn't do something specific. It's the fact that it marks something, which is await only works in an asynchronous function, or, if I have support for top-level await, it works at the top level, so in the global namespace of modules. Now, this whole module business we're going to discuss on another occasion. Suffice it to say that if I write a library in JavaScript, the way it exports functions is one of two variants. And there's a classic variant and the module variant. And if I'm in the module variant, I can use top-level awaits. Again, I don't want to go into details right now. But so the simple rule is I have async because I can only run this I can only await something in an async function. And here we have an async function. And I see that my code has become really similar to my non-asynchronous code, right? So I just have to put await. So result is await F0. And this is going to wait for the result of F0 before running the new line, the next line. Now, if any of these is rejected, and I notice that this one is rejected, just cause. What's going to happen is I'm going to get an error, and I can catch the error. So I have my regular try-catch code, which catches an error. It's just that the code is asynchronous.
So what does warn do?
Does what?
Warn. Dot warn.
Oh, so console, being the object that writes to the console, can write various things, right? Now, if I use this in a console application, it writes to various streams, actually. Right, so you have console.error, which writes to the error stream. The other stuff writes to the output stream. Now, the difference between warn and log, besides the visual maybe aspect, is the fact that if you print something to the console in Java, in Python, in whatever, it doesn't have that much of a priority. Right, so if you just write a for from 0 to 1 million in Java and you write stuff to the console, stuff is not necessarily going to come in the order you're trying to write it. Right. So how do you give something a priority? Why does it matter first, and how do you give something a priority? So it matters because if you write stuff with console log, there is no obligation for the log to go through before the program crashes. So it's sort of bad practice to write exceptions with log, because the program might crash because of an exception, and it might not print the exception, just cause. Right, and this is an operating system behavior thing, right? It doesn't have anything to do with JavaScript. So the way to work around this is you have an implementation which is different, which is warn. And these correspond to those classic error levels. If you look at logger levels, right? So loggers have levels, and the methods in console correspond to the logger levels. Anyway, so you can use console warn, so it does get printed, and then the program dies. So that's why it's warn. In the browser, I'm going to tell you sincerely, I don't know if there's a difference. Besides with the visual thing. Because the browser, you know, the behavior is, we have to look for the engine. I don't know if they have different behavior, right? Just like in, I don't think they've emulated Unix streams in the browser. That makes sense, right? Maybe they don't necessarily, but in a console application, it's important. Right, so I get 2 results, then something explodes, right? And I don't get the third one. You know, it functions just like anything with try catch. And something crashed, execution stopped, I got to catch, etc. Right. Of course, if I don't want to catch the result, I can just run the function. It's going to run independently. I'm just not going to know what happened. I might want to do that. For example, I might want to respond to an HTTP request and then asynchronously do the operation. The second question is, well, have I given up synchronicity for this? And the answer is no, right? I can run them just like before. I also have some mechanisms to manipulate all of it. So, for example, if I look here, so I have the same promise structure, but I also see that on the promise type, I have a method called race. So what all does is it's going to receive an array of promises, and it's going to finish when the last one finishes, right? So it's going to be fulfilled when the last one is fulfilled. If one of them is rejected, the all is rejected. And if you think about it, these are executed in parallel, which is important. And it's as slow as the slowest one, right? Because it has to wait for all of them. While race is fulfilled if any of the promises is fulfilled. It's fulfilled as soon as the first one is fulfilled. And we don't get and we don't care about the other results. Right? So it's the first one, it's as fast as the fastest one. Right, so this would be the promise business. Let's look at the final example about the promise thing, which is we had this function, and the function, let's say, had callbacks. There's no reason for this function. This is artificially asynchronous. There's nothing to wait for. We just divide numbers. So this has a success and error handler. This is something which frequently, if you look at various, well, it's in a lower number of cases than before, but there used to be a lot of code which was callback based on the internet. So you'd run into this code, this kind of code all the time. Or the alternative in which it's something with if error and so forth. Right, so let's promisify this code. So what we have to do, we're going to write this structure. The structure we're going to write every time, right? So it's always return new promise of function of resolve reject. And inside, notice what we've done. So we've replaced success with resolve and replaced error with reject. And this sort of hints at how it's done automatically, right? The functions are replaced with different functions. So this works, and it now works in a async await context. Right. So that's the promise discussion. If you have any questions about this bit.
So what was exactly the difference? I mean, what dot race, that's the method, what did that do?
Yeah, so race is the promises, right? So the first one who finishes is the result.
Okay.
Let's run it, and we're gonna see what I mean. One sec. Right, so notice that the race finished first, right? That's because it only had to wait for the fastest one. There's no way for these to be rejected, as an aside. It's because it's a school example, there's no way to reject it. So, so the fastest one took 100 milliseconds, which means I got the result for it, and it's F2. Whilst for the all, it had to wait for everything. Now F2 still finished in 100 milliseconds, but the all couldn't be resolved because I had to wait the further 100 milliseconds for F1, and a further 100 milliseconds for F0. Make sense? Right, so that's what they do. They're useful, you know. So for example, if I have to insert 10 users in the database, right? Let's assume the database doesn't support array insertion, which is how it's actually done. I have the array, and I'd say, well, for each of the elements in this array, do an insert, right? Right, but if I want to get the result, I'd say await do the insert, which means this is going to take, in time, the sum of 10 inserts. But if I do promise all of pre-constructed promises, it's going to take one insert, whatever that means, one average insert. It's I don't necessarily know. They're not going to take the same amount of time necessarily. The database does. No database is going to give me a time for how long an insert is going to take. Right. So, other questions? So onward then to HTML. So I said that the triplet of technologies I'm using are going to be HTML for structure, CSS for presentation, and JavaScript for behavior. But obviously there has to be some relation here, right? I have to be able to manipulate HTML and CSS from JavaScript to some extent. So I'm going to see what the relation between these is. But first, let's talk generically about HTML. It's not this one. I don't know what this one is doing here. This one. Right. So HTML is a structured definition language in the sense that what it actually does is define a tree. But from a different perspective, HTML, it even says in the name, it's hypertext markup language. What would be a markup language? Well, I can think about the markup language as if I would underline a book with a marker. Right? So when I underline stuff in a book with a marker, what I'm doing is I'm overlaying some semantic thing. Right? I'm saying, well, orange means important. Right? I don't know. Never done that, by the way. So the problem I'm going to have is that my semantics are really limited. How many different colors can I put there before I can't distinguish between the colors? Not that many, right? Right, so that's a way of thinking about it. Well, so let's advance over this actually marking thing and think about HTML tags as parentheses, right? So I'm going to use parentheses, which I'm going to put around code, to signify meaning. I'm going to say, well, I'm going to use square brackets for important. Well, that's fine too, but again, I'm going to run into a barrier of how many parentheses can I use. So these are my parentheses, right? So this is the open parenthesis, which is represented as a name of the tag between less than and greater than. This is my open parenthesis, and this is my closed one. Make sense? Right. So I can put any piece of code between these parentheses, and it means something. It has some semantic. That's what I'm trying to do. I'm trying to define some additional meaning. Right. So this is my standard HTML, and I noticed that it has two great sections. One of them is with the showable stuff, which is body, and one of them is with the non-showable stuff, which is meta information about showing stuff. So it's the content and it's meta information about the content, which I'm going to find in the head. In a simplified way of looking at things. Right, so now, because my parentheses are the name of something, I can have limitless parentheses. It's absolute power. They're still not flexible enough, so I'm going to have an extension to this as well, but they're good enough for now. Right, so this time, again I see some HTML, and there's something interesting happening here, which we're going to briefly comment on. There's a shoe, right? So the question is, how did the browser know that was a shoe? And there's a neat engineering trick here at work. So what is Unicode? What is Unicode? Right. So let's talk about let's make it simpler. What can I do with Unicode?
Symbols.
Yeah. So it's represent the symbols for a bunch of stuff, any language. For example, Unicode. I don't know if you knew this. Supports Klingon. The Klingon alphabet is part of Unicode. Now, the way it's actually defined is it's a structure of pages and elements on pages, right? So it's the old segment offset representation. But Unicode gives you the number of the character, but it doesn't give you the representation of the number, right? So you have the number, but you don't know what the bits for the number are. So the representation, though, is one of multiple things. So for example, UTF-32 is on 32 bits. UTF-16, which is what Windows uses natively, is on 16 bits. And UTF-8 is not on 8 bits. I know, the classical transition would have been to be on 8 bits. Now, what is on 8 bits is ASCII characters, right? That's how much space ASCII characters need. So, what would UTF-8 be? Well, UTF-8 is a way of representing Unicode codes on variable length characters. Now, the reason why it's variable length is because, incidentally, ASCII characters look exactly the same in ASCII and in UTF-8. Why is that important? Well, because I can do the following sleight of hand. So I know that the tags in my file are written with ASCII characters, which means I can read the file assuming its encoding is ASCII. I am the browser in this story. So the browser can read the file assuming it's ASCII. This is going to allow it to understand all the tags, but not necessarily the text, right? ASCII doesn't have a shoe. Right, but after I've understood the tags, I can read this tag. So I can reinterpret the text and then know that this is a shoe character. Make sense? So it's a bit of sleight of hand in the sense that I can make the wrong assumption, but it's still going to allow me to interpret it correctly. It's like flying by pulling on your boots, right? I'm reading it wrong, but I'm ultimately interpreting it right. Right. So this is interesting as a mechanism. I just wanted to point it out. Now, getting back to our HTML. So HTML was initially a document representation language. It's part of a family. It was an instance of something which was called SGML, which built languages like this. In the meantime, it's something in itself, so it's not connected to HTML nowadays. However, so I said I will use HTML as a structure definition language. So ideally, it would just represent structure. It would be pure structure, right? If I were to think about how something that represents structure looks, it shouldn't look in any way. It should have no presentation characteristics. Now, this is not necessarily true because HTML is somewhat backward compatible, which means these obviously look a certain way. They definitely have some style characteristics and they come from the browser itself. And the reason is because HTML having a storied history, I can still look at the first web page, which looks like this. This is the first web page. Yes, this is from CERN. It's the presentation for the World Wide Web before the World Wide Web was popular, before it was cool. And the source looked like this. It's a bit different, but their vision was that you're going to represent documents. Now, in the meantime, things have evolved a bit, in the sense that we're not representing documents. What we're representing is the structure of graphical user interfaces. But that is why elements like heading still have the same presentational characteristics. Now, as with any language, if I have some sort of reserved character, I have to have an escape syntax for that reserved character. And in this case, the reserved characters are going to be less than and greater than. And the escape syntax is going to be this one. Right? So it's ampersand LT semicolon. Now, obviously, whenever I have an escape sequence, I have to have an escape for the escape sequence. Right? It's think about C strings, right? I have \n, but because backslash has some significance, I have to have \\, and in this case it's ampersand m. So not really anything new, it just works. Now, what about this thing? Well, this is interesting. Notice that the second line, which is at line 4, isn't written on the second line. It's written on the first line. Right? So what happened here? So what happened, it's interesting to think about why this happens. So what happened is that the browser has, the default behavior is something which is called white space collapse. That means consecutive spaces or space-like characters, that is tabs, enters, are going to be replaced with a single space. That is because I'm not supposed to tell the browser how it's going to display text. Right? The browser knows how to separate things on lines. If I wanted the things to be on different lines, that would mean they had different semantics. They meant different things. And if they had different semantics, they should be in different tags. Right? But if it's, so I'm not supposed to tell the browser, look, this is a line. If I want it to be a line, I can put a div, which represents the idea that it's a separate line. And to see why this perspective is useful, let's find some text. Right? So look at the lines on this thing. No, that was wrong. See, the number of words on a line rearranges itself. This is the responsibility of the browser. It's not my responsibility. Right. If I really want to do this, but although it's a bad idea, I have a tag which represents a manual line break, which is BR, and I can use this horrible thing, which is a non-breaking space. That is a space which cannot be collapsed, but I shouldn't do that. Now, if I want separate lines, I can do it like this, right? Obviously, I can have separate paragraphs, which I can style however I want. And this is going to tell the browser these are separate, the first of a thing and the second of a thing, whatever the thing may be. As for this is pre-formatted code. The tag still exists, and it's there to exactly for this use case. That is, I want to show some code and I want to keep the indentation. However, this also is not something really currently relevant, because to show you an example, and we're going to look at this at some point when we discuss about classical applications. I wrote a pastebin. I wrote me a pastebin, right? And wrote myself a pastebin. And see, this does syntax highlighting, but and it maintains. But this is not pre-formatted code. This is something which parses the code. It's not. I didn't write it by hand, obviously. It wouldn't have been right. And this is the pastebin, so I can send this link to somebody and they get the code. Right. So that is of limited usefulness. It's fine. It exists. It's great. Right. What else? So it's a hypertext markup language. So the hyper comes from the fact that it has links. Now, if you think about it, the whole link business had to be invented. So if you think about how you would organize masses of text in the old days, you would have had indexes. Right? So you had a part at the end of a book, and it said, well, for something relating to this word, go to page 95. And this was actually invented. So the idea of linking text was invented, and this is why it's called the web, by the way, because it's like a spider web. Right, so a link is going to get me to have a URI, and it's going to take me to that URI based on, when I click it, based on this particular attribute. But notice something else. I have attributes. What are attributes? Well, I said that initially that the reason why I have tags is that I couldn't have that many parentheses. Well, even in this, I'm still pretty limited, because what would I do? I would create a different tag for each possible link. That doesn't make any sense. So instead, what I want to do is for links, for the tag for a link, which is a anchor, to be able to have some attributes which I can customize. And it has a bunch of attributes, and the attributes are key value pairs, and the pairs are separated by space, right? Which means that if I do this does not mean the same thing, right? So I can't use spaces. Now, as for the values of the attributes, they're typically strings, and I can write them as strings between double quotes, single quotes, or I can write them without quotes, as long as there's no ambiguity. What would ambiguity look like? Well, it would look like a space. So if the value has a space, I have to put it between double quotes, because it's going to be interpreted differently. Now, as for the links, remember that I said that a web server delivers content from a directory which is called the web root. Well, within that directory, I can move around, right? I'm not, it's not flat, right? I can go to subdirectories, I can go to parents, etc. And the way I move around is just like in the operating system. That is, I have the little dot, which represents the current directory, and I have the double dot, which represents the parent. And this allows me to move around in a tree-like structure. So that's the links. So what else? Well, HTML has some prepackaged displayable things, components. Now, what's great about these is maybe they're not going to look stellar, but I know they exist everywhere. Right? So I can rely on these existing. In this case, I see a little list. So it's a UL, unordered list, containing list items. And there's an OL, ordered list, containing list items. Now, we're going to go back to this at some point, but if I think about what's special about the list, is, without necessarily talking about it, what we've seen until now is little displayable rectangles. Right? So everything was a little displayable rectangle. In this case, it's not just one rectangle, is it? It's two of them, which move together. Right? So this has particular style, but the style is special. It has a marker, a list marker, and the list content. Now, about what is displayable, I forgot to say something, so I'm going to go back a bit. So we're going to go back to the headers, the headings thing. So notice that I said that I semantically mark stuff, and this is H1, heading 1, heading 2, heading 3, but there's the div. Well, the div is something which means a single thing. It means this is a division. Now, if I think about inserting a picture, an image, in a Word document, how can the image behave? There's two general ways in which it can behave. No, it can behave as a paragraph, or it can behave as a character. And these are generically called display as a block and display as inline. Right. So these are if I talk in terms of typography, these are the generic ways of showing something. So what would be a block? Well, a block, which is displayed as a paragraph, which is represented by a div. A div means something which is block displayed. Doesn't allow anything on its left or right, right? It breaks the text vertically, right? It occupies all the horizontal space, no matter if it's 1 pixel wide. Whilst the character, well, character behaves a bit differently, right? So it's in line with the other characters, and it's spaced on the right and the left by something which is the character spacing, whatever that is, right? Which is the default space between characters in whatever font you're using. Right, so that's the span. Right? So I have these generic things which represent something which is block and something which is in line and nothing else. Okay, so 1 second. We were at the list. Now this, I can use something else, which is this. This is a table. Now a table, this allows us to talk about something else which is interesting. So a table, if I look at it, again, all of these have pre-existing style instructions, just like the headings. So a table has a header, and the table has a body. Each of them contain rows, and the rows contain cells. Now, the cells are identical except for this styling thing. So TH looks different from TD, but yeah. But let's notice something interesting. I said that a T-head contains rows, but there's no row here, right? So let's just point it out. Now let's look at what happens in the browser. Well, if I look at T-head, I'm going to notice that I have a row. It appeared via magic. Well, the answer here is that the browser tries to make things work. So in this case, it created the table row, which I forgot. Right. Now this is an image. Again, it's based on a URL. Do you know what this image represents? What this is? What is this? Yes. Is there something special about this computer? Yes. It is the first personal computer. This is the first personal computer. Do you know how this is programmed? Can you infer? No, it's not. This is a modern computer. The way it works is you have to take it byte by byte. You have to flip switches to define the byte value. You insert the byte value, and then you advance to the next byte, and you flip switches. All right, and Microsoft. The first thing that Microsoft wrote Bill Gates actually wrote, was a basic interpreter for this computer. It's interesting. It's a little piece of history. It looks horrible indeed, but you know, probably at that point it was magical. Right. What else? So I said that this is the structure definition language. So let's see some structure. This is the structure of the, how should I call this? The basic web page. The most basic web page looks like this. It has a header. It has a sidebar on the left and the content pane on the right. Right. That's the I don't have any different structural idea. This is the basic web page. Right, so let's see how it looks and what we've accomplished here. Well, it looks exactly how we want it, which is in no particular way. Right? I said that we want structure definition. The structure is all right. And it doesn't seem to have any additional style information. But there's still a bit of an issue here, right? Because let's see what we've done. So I see an attribute called class. So we've already seen attributes, but some attributes are what are called global attributes. That is, every tag can have them. So let's look at some examples of global attributes. So I can have an ID, which is supposed to be unique, which is the ID attribute. I can have inline styles, that is styles that I put directly on the tag, which is the style attribute. I can associate classes, which are CSS classes, with the class. I can also do a bunch of other stuff. I can use, I can say, if I navigate the page with tab, in which point in the order would this element appear, which is tab index. I can put shortcuts there. I can specify the text direction, if I'm in a language that has a different direction from English, right? Because there are languages which are right to left, up, down, etc. Another interesting one is that I can, at this point, I can use a global attribute which is called content editable, which is going to allow me to edit the content of any tag, which is marked as content editable, from the browser directly. So any tag is an input, so to speak. Right. So let's get back to class. So what class is presumably supposed to do is it's going to allow me to assemble CSS classes to get to some outcome. So for example, if I have a button and the button is large and it's a positive button, it's go forth. I'm going to say large positive button, right? These are going to be the classes, and assembled, they're going to give me how the button is going to look. They're not necessarily supposed to have semantic meaning. Well, these things aren't here to say something about display. They're here to say something about semantics. Right? Divs have no inner semantic value, right? They don't mean anything except division. Right? It is just a thing that groups other things. While here, I put semantics on it by putting something in class. And in even more modern HTML, I got a solution to this sort of thing, in the sense that I got some tags which basically mean div which is header, div which is main. Right, so instead of putting these classes, I have tags for many of these situations, or for most of them. Right, so I can use these and avoid that, although I can still do it with divs. The last thing last-ish thing we want to look over with the HTML is we have forms. Now forms are involved in the, let's say, traditional flow of a web application. That is, the assumption was that I ask for a text resource from the server gives me text resource contains a form. Form contains inputs, I write stuff in inputs, I press the submit button, which has a special purpose, and when I press it, the submit button packages the form in a neat little string and sends it via the method to the action. The action executes itself and it has some output, but instead of writing it to the console, it writes it basically as a response to me. The response contains another form, and we go through this again and again and again. So that's how they were supposed to work. We're not going to do that, but we're going to see it in a course, just so we see how you would organize a classic web application as opposed to what we're writing. Now, the good thing about these forms is that they give me standard inputs everywhere, right? So I can assume that these inputs have the traditional behavior on any platform which has a browser. Now, something else to notice is this form contains a bunch of inputs. Now, when the browser, what number was this? Was 13. Okay, 13. So when the browser parses this document, right? So if I look at my source, it looks like this. Nothing is visible, I'm betting, right? It looks like this. It's in order for me to be able to interact with it, it's going to build a tree, right? And the tree is made out of objects, and these objects look exactly like you'd figure a node in a tree looks like. That is, the simplest representation of a node is going to be, it's an object which has whatever properties it needs, but also a collection of children. And notice that indeed, if I look at the source, I would expect to have two children, this input and this input. However, I can notice here that I also have a collection called child nodes. So the relevant question becomes, what's the difference? Well, the difference is that apart from the children, which are HTML elements, which in turn, HTML elements are event targets, which are nodes, and so forth. So there's a whole structure of object types. So apart from the HTML elements, I also have some text nodes. Now the reason why I have some text nodes, text input, is if I think about displaying this form, this thing is going to be a little drawable rectangle, right? It's right. But this, even though it's not an object in itself, or I didn't explicitly make it an object in itself, also has to have a little rectangle, right? It takes up space. It has to take up space, so it has to be computed in position, wherever that may be. So that's why I have the text nodes. Now, as for the getting back to forms, the forms have your classic input text, input radio buttons, checkboxes. So radio buttons have one value, checkboxes have multiple values, can have multiple values. I also have drop downs. I also have password inputs, which hide what I'm writing. I also have hidden inputs, which add additional information. I click submit. If I want a button which doesn't automatically submit, I can use input type button, in the original logic. But I can also click submit, and submit is going to package all of this and send it. What do I mean by package it? Let's see. So if I click this, my form has no action and it has no method. So in confusion, the browser is going to make some assumptions. Right. The assumption is I am sending this to myself via get. So I can see how the parameters are encoded.
So I have to use even default or something?
Well, we're going to get to that point. Not necessarily. It depends on what you want to do. In this case, we just wanted to see the parameters. So I see the parameters are URL encoded. That means that there are a list of key value pairs. Now, who's the key? Well, the key is whatever I've written in the name attribute. And the value is whatever value you gave it, right? So in the text input is what you've written in the input. In a radio, the value is defined here. Right. Now this is, for example, if I want to send an ID, it's something calculated behind the scenes. As an aside, those were the, say, traditional controls, but there's a bunch of modern controls. And this is another bit of engineering sleight of hand. So this is a demo I can no longer make. I'm going to show the controls, but I can no longer make the demo because. So at some point they introduced a bunch of controls for email, telephone, search, etc. These might be something which allow you special input, right? So you can select a color from a pane of colors. Or they might just be something which works like a client-side validator, just for email. And initially, at least, these were not implemented, right? It's not like you flip a switch and it appears in all browsers. But they worked from day one. Because what happened is if the browser didn't have a special control for color, it just gave you a text input. Right? Because basically what it did, so no matter how you select it, the result is a text input. So it just gave you a text input. And in time, they were all replaced with their actual form. which is why I can't demo this. So I can show you the controls, but in time, like somewhere in the past, some of them worked, some of them didn't work. But since they now all work, it's I can't. They all work. So they do the kind of input. So the whole text input reasoning is not demoable, but it used to be demoable.
How hard is it to modify this input?
Do you want to? What do you mean to modify the input?
For example, the date, the format of the date, or how it looks when we want to select a date.
There you can do it from your own code. As an aside, you can actually build this. It's not that hard. You can actually build something like this. If you look at most of the selects you're going to see on the internet, for example, they're built from scratch. It's just we're going to get to CSS, but the idea is that it's just an overlay pane basically, which is attached to the position of a text input, because you don't have, for example, custom option rendering, right? HTML select doesn't support custom option rendering. What do I mean by that? Let's say you want to select, like we had the countries, right? But instead of just having the country name, you also want a little flag. There's no way to do it. Right? These are supposed to be basic controls. But there's nothing stopping you in using a text input, right? And decorating it so it supports that sort of logic. So it's not that, how should I put it? It's not that hard or impossible, right? So you can build any of these controls, but you can't necessarily modify the fundamental control. Or maybe it's not worth it. So yeah. All of this is stylable to a certain extent, but I can't tell you if you're going to reach your. What I can say, you can implement whatever you want under the constraint that you're going to build it yourself. That's how you're supposed to regard it, Right. So there's a bunch of So now we're not going to go through all of this, but let's go through some of this. So how do I interact with? So I have this object model. How do I relate to it? So first of all, this is a button. It's an input type button, and when I click it, it does console log hello. This is the oldest way of doing JavaScript in the browser. Notice a couple of things. So onClick is really old, which is why it's not written camel case. There's no separation between. Second thing, how would this actually work? Well, the way it works is whatever code I've written there is packed in an anonymous function, and that's what's run on onClick. Let's see that it works. Let's see if it says hello. It says hello. Right, so that's one way to do it. Obviously, this is advanced in time, so let's advance as well. So here, let's notice another limitation / characteristic of our situation, which is I have a button. I can associate some behavior to the button by getting the corresponding object and adding some sort of listener to click. There's two ways of doing this, and the traditional way is I have this special property, which is onClick. There's not just onClick, it's also on focus and so forth. So I can put a function in onClick, and that's going to be my handler. And this is what I'm doing here. Right. How do I get the button? Well, I can get it through a function which exists on any HTML element, which is going to get an element by ID from its descendants. I can do it on document. This is going to handle all elements. Document is a global object representing what I've got rendered. This is the fastest way to access something by ID. Let's just see it in action.
Aren't IDs already present as properties of Windows or already defined as variables? Isn't it that faster?
What?
And if you haven't a button with an ID or something, then something is already property of Windows, it's already defined. You don't even need, if I remember correctly.
I don't understand what you're saying to me. Sorry.
Remove the line with the continue one, and
What line? This one?
No, yeah.
No.
Let's go through this one.
Oh, okay.
So all IDs are defined as globals.
Oh, okay.
Rectangle.
Interesting to know. Thank you. Now, the reason why we went through this is let's see what happens if I move it here. What's going to happen?
First it loads the code and then
It crashes.
Not before the.
Yeah, that's because the order these are run in is the order in which they appear. And if you look at this one, right, it appears before the button actually exists, which means that document get run by ID is going to give me null, null doesn't have on click, etc. Right. How would I handle this? Well, I need to wait for things to load. Yeah.
window.onload.
Yes, window.onload is going to give me an event whenever everything is loaded.
So I'm scrolling to the and there was another one.
Yes, it's document on DOM content loading.
Wasn't there also something like defer or script?
Yes, there was something like defer on scripts, but we're trying to see the life cycle right now. And now, this is going to work. Right? Because everything has been loaded. Now, what does everything mean? What's been loaded?
The button.
Let's look at this one. So, first of all, why do I have a bunch of things here? Yeah, but how did I get to that point? let's look at the source, right? So if I look at the source, I'm sorry, I hope it's visible. I'm not going to. If I fiddle with the colors, it's going to take a while. Right. So it got to something. Let's just pick something which sort of makes sense, right? It got to this CSS thing. And when it got here, the browser said, well, I need something additionally to load this page, right? So I'm going to make a separate request to get that thing to show everything. So window.onload is going to mean that all resources are loaded, which I may or may not need. So anyway, the idea is these are executed in order, and in this case, I can run it on load. Right. Now, on click, like I said, is the is the traditional ancient way of doing things, but there's also a more, let's say, more recent interface, which has add event listener and remove event listener. Now, it's a bit more complicated to manipulate, and I have to, so for example, if I have some code which is going to add listeners, maybe I have to concern myself with removing the previous listeners. But of course, I can customize the behavior if I need to. Where is this? It's there. Right. And it has the values and so forth. Now, let's talk a bit about events. So, if I click D3, what's going to happen? What am I clicking? That's an interesting question. What am I clicking, right? So, D3, D2, and D1 occupy the same space. If I have a tree and I'm clicking a leaf, what am I clicking? Am I clicking the root or am I clicking the leaf? Well, it depends. So in the JavaScript variant, I can actually modify this behavior, but generally I cannot, depending on language. So the default behavior, so the default interpretation of this is that events bubble up, right? That means whenever I'm clicking something, I'm actually clicking the most specific thing, and then it goes to the less and less specific thing. So in this case, D3 is the most specific thing, and D3 is going to get the chance to run any handlers it has for click. Then it's going to bubble the event to D2. D2 is going to get that chance, then D1, etc., and until it gets to window, and then there's nothing over that. And so this is event bubbling. In JavaScript, I can actually make explicit events which have a different behavior, which is called event wrapping. So they start from the most generic thing and go down. Generally, you're going to want the events to bubble. In this case, though, let's see what's going to happen. So I click D3. D3 has the chance to run something, and it says click D3. Then it bubbles the event. Notice that I didn't even put the event here because I didn't really care. I don't have anything to extract from the event, so I just signaled that by not using the parameter. Here, I do something else. It says event stop propagation. That's going to make so after D2 runs its handler, it's going to make the event not bubble up anymore. Right? So everything stops. It never gets to D1. Obviously, I can add events either by putting them in event handlers by either putting them in on click or by using add event listener. Let's see. Right. It stopped at D2, didn't go up. Now, this is another interesting thing. So I said briefly that what I see in the tree are actually my DOM nodes. So for example, let's say it's a div. Right? So that div is going to be an HTML div element, which is going to inherit an HTML element, and so forth. And at some point in this hierarchy, I'm going to have an event target. Now, event target is going to be something that receives events. But the events are not necessarily only the ones predefined in the browser, in the sense that I can create my own events. We've already briefly seen this when we talked about the synchronicity. I can notice something else here, which is going to come up next time. So I can get something with getElementById, but getElementById seems pretty limiting, because it's actually, what if I want to say I want all divs which have the class awesome, right? I have to have a mechanism to work with that. And what I'm going to have is a couple of methods which are going to work with CSS selectors. More about CSS selectors next time. But query selector is going to give me the first element which matches, and query selector all is going to give me all the elements which match. So this is actually the equivalent. It's a roundabout way of writing getElementById. It's just so we can introduce query selector. Anyway, so notice that D1 doesn't have any handler for click. It has handler for an event which is called alarm, which doesn't exist in the browser itself. It says I'm no alarm. So what I'm trying to do is I'm going to mediate the click. So I'm going to click on something else. That something else is going to create an event of this type, alarm. And because D1 is an event target, I can actually send an event to it manually. It's a bit roundabout, but this is going to show me that I can make custom events. Right? So if I click this, nothing happens. But if I click this one, this works. Right. Let me just close other tabs. Right. Now, what else? Well, some of the tags have some default behavior. So, for example, we saw the submit button, right? So when I submit the form, it packages everything, sends it via the method to the action. I have no idea what's here. What? 1 second. Anyway, so in this case, what I did is I got the link, and the link, whenever I click a link, it navigates to the link. That's what it does by default. But in this case, I see I can do event prevent default, so I can prevent that behavior. Now, it doesn't matter why I do this. Maybe I want to use links in place of buttons. What's interesting is that my handler is going to actually run before the default handler, or otherwise it would be useless. Right, so that didn't work. Didn't do anything. Additionally, something else of note is the fact that so I have a generic event definition, but events are going to have characteristics which are dependent on the event type. Right? So, for example, if it's a mouse event is going to know the button which I'm pressing. A key event is going to know the code. So some events, for example, when you saw I ignored the event, for example, if I did window.onload, I don't really care about the content of the event. If I want to click on a button, I don't really care about the position of the button, of the click. But if I elect to have as a parameter in the handler the event type, right, I can extract additional stuff from it, but which may or may not be relevant depending on the case, right? If I click on a canvas, probably I care about the position on the canvas. But if I click on a button, the button itself is enough information that I don't actually need to know the position. I don't care where the button is. I care that the OK button was clicked, but not its position on screen. Right. I think this is about it. If you have any additional questions, we're going to continue with the DOM manipulation a bit next time.